first of all, I've just seen what Dawn just said and what Andy said at the beginning as well. So the topic I'm going to talk about is a little bit advanced. So if you are really, really new to Puppet, this might kind of leave you a little bit in the dark. But hopefully, like as you learn a bit more about Puppet, this is something you can come back to. So I'll say that from the beginning. So a little bit about me. So my name's Craig Dunn. I've been a Puppet user since about 2008. I started on 024 while I was an IT contractor in the UK. I joined Puppet Labs in June 2012. So now I'm a professional services engineer, which means I do consultancy and trainings and all sorts of fun stuff like that with our customers. And if you want to hit me up on Twitter or IRC, that's my details. So what I want to talk about is Puppet design, and typically how people actually design Puppet. I'm going to use a real-world case study, which was actually how I got to actually come up with this design in the first place. It was actually while I was working on Puppet in a really large implementation. I'm going to have a look at thinking about the components that you're managing in Puppet and how to think about those properly. And we're also going to cover a section on node classification and data separation with Hiera. So a bit of background. This, what I call the roles profiles design pattern, actually came out because I wrote a blog post on it back in May. And it just seemed to resonate with a lot of people. And a lot of people on the mailing list have been talking about it lately. Has anybody actually heard of this roles profiles design thing? Yeah? 2, awesome. I won't bore everybody then. So it's a way of designing Puppet that's actually advocated by quite a few Puppet Labs engineers. And people in the community have told me they've been using it with success as well. And just the general design really solves a load of problems for them. And as I said earlier, it's based on a real-world solution. So this isn't just something I sort of thought up one day. So when we talk about designing Puppet, one thing you're probably doing at the moment, or hope you're doing at the moment, is you sit down, you write awesome modules, brilliant, and then you assign them to your nodes, and everything works. So that's kind of the stack. So there's nothing inherently wrong with this. And it's how most people start out. But down the road, your infrastructure is going to grow. Your business requirements are going to change, and they are going to get really complex. And at some point, you're just going to feel like your Puppet code is just getting really bulky. It just feels like high maintenance. It's like you get a request to do something in Puppet, and it's just like, oh, you've got to hack it in there because stuff's just not fitting right. And if you think you don't have any edge cases, they just haven't happened yet. You're always going to get edge cases. And so eventually you're going to sit down like who's been using Puppet for quite a long time and has written a code base and then gone back and refactored it from scratch? Yeah? Yeah, quite a few. Because it's a really common thing. This is not an unusual problem. So some danger signs when you're designing Puppet stuff. If you start to see any of these, if 2 or more of these resonate with you, then it's probably time you start thinking about designing your own Puppet code base. So if you start finding that resources are being declared in 2 modules and you've got conflicts and you've got to start having to say, if it's not been defined yet, then declare it, otherwise do this. If that second line actually means anything, if you just sort of sit there and go, I just don't know how to make all this stuff fit, it just won't gel. And one thing I'm going to talk about in a minute as well is lots of logic at the node level. And I'm going to come on to that in a minute. If you find yourself with a lot of repetition and a lot of duplication, again, and particularly that bottom one, I think that's true in kind of a lot of languages as well. If you find you're using the if statement all the time, you probably need a better solution. So the first thing you're going to do, I hope, is to make sure you're writing good modules. Yeah, so your modules, they should be granular enough that they're only managing their own resources. They should be portable. And there's tons of guidance and documentation out there about how to write awesome modules. So there's no reason why you shouldn't be doing that. But then where there isn't a lot of discussion is thinking beyond just writing modules. So actually thinking about Puppet as a code base and how do you design an effective framework around it? Because Puppet is a sysadmin tool, but it's code. It's a code base. So as much as hands out who's a sysadmin versus a developer. Yeah, so most of the room are sysadmins. If you're going to use Puppet effectively, you have to think a little bit like a developer because it is code. And it's just because it's a sysadmin tool and just because it's helping your job doesn't mean it's not in any way code. So we're talking about gluing everything together. So node level logic, excuse me. This is basically when you've got too much information tied just to your node. So when you do that, you risk duplication and repetition, because for every node you've got to keep defining all this data. You've got no guarantee of consistency and TMI, you've just got too much information. So that, for instance. I don't really want to look at node Bazel and find out it's got class Apache and MOTD and SSH and users with that shell and that. That's way too much information for me just to be tying to like node Bazel. Because when I have like another 1,000 nodes or another 10,000 nodes, that's like a huge amount of code. So this is talking about where you should actually start implementing this stuff. So what we're going to look at in this particular way of designing Puppet is going to try and provide some business logic to node classification. We're going to provide an abstraction layer to actually implement all our components. And that's going to make our code more adaptable to complex business requirements. We're going to reduce that node level logic. And we're going to reduce this sort of functionality overlap. So an example I'm going to use is you just written some nice, really beautiful, clean Puppet code. What's the worst thing that's going to happen to your code? It's going to be business requirements. Yeah, it seriously is. Because business logic doesn't always align with technology. Yeah, it just doesn't. So the case study I'm going to use, this was a real world problem. This was just before I joined Puppet Labs. So the 6 to 8 months before I joined Puppet Labs, this is very much what I was asked to do at a client site when I was contracting. And at the end of it came out the blog post and this whole sort of idea of a roles profiles design. So the first thing that happened is the business comes up to us. We've got 3 applications we want to deploy using Puppet. And we're like, that's awesome because we write Puppet. Let's do it. So we asked the business, okay, show us what you got, show us what you need us to put into Puppet, and we'll do it. So they did. So we have application Y, X, Y, Z. The business view is this. They just see 3 separate applications. They want them in Puppet. So we're like, all right, we'll do it. So we went forth and puppetized. We just jumped right in. And the first thing we did was take the business requirements, which was deploy application X, Y, and Z, and started writing 3 Puppet modules, because that's what the business told us to do. Yeah? Things got pretty painful fairly quickly. And we just started to realize that all of those things on that danger sign slide, what I told you just now, were like all of those things were happening. And like the image I've used there is because it really felt like just trying to sort of hammer a square peg into a round hole. Like just nothing was fitting together very well. And we kind of identified some of the problems and some of the reasons. And we looked at what we were doing and we're like, hey, you know, these applications, they're not that different. You know, they seem to have a whole bunch of stuff in common. And this is why we're having all these problems with these 3 Puppet modules. And we're like, you know, the implementation differs on all these different environments and locations. But writing 3 separate modules is just giving us like loads of duplication. And it was becoming unmaintainable very, very quickly. This was like the first few weeks we were trying to do this. And we kind of sat back and tried to think, well, what are we doing wrong? And we sort of came up with, well, we're trying to code business logic. You know, we're trying to take business logic and just code it without any thought at all. We're just like taking off the business, chucking it into Puppet, and maybe that's where our pain's coming from. So we kind of made a decision. We thought we're going to stop thinking about what it looks like, and we're going to start thinking about what it is, what it actually is. Because what it actually is probably is not what it looks like to the business. So to do that, it's like granularity is the key. We break all these components down and see what they are, see what the building blocks are, and how we're supposed to assemble them to achieve what the business wants. So what we actually realized when we did this is that each application stack that the business called them was actually just a collection of like Java apps, and each application was a collection of the same subset of the same bunch of Java apps, and they were just implemented in different ways. So, you know, there weren't really 3 applications at all. So the business view was still this, and that's still valid. Like, you know, from a business point of view, they don't care if it's in Puppet, if it like doesn't work. They want to see application X, Y, and Z. But the technical reality of this was different to the business logic. So, okay. So we actually only have one application, is what we realized. We're just implementing it many different ways. So we thought, well, how do we, okay, so now we've realized what the problem is. How do we deal with it? Because we can puppetize the application, but if we've got to implement it in all these different ways, how are we going to solve that? So we had this idea that would reduce all of these little Java sub applications into individual Puppet modules. So we'd break everything down into the components as granular as possible that we were going to use to build our application stack. And then we thought, well, we'll create like an abstracted code layer above all this and have that code layer responsible just for implementation. And hey, let's call them profiles. Why not? It's a good name. So that's kind of what we came up with. So we thought, all right, this is at first what we came up with. So okay, so now we've got a profiles X, a profiles Y, and a profiles Z. And all these do is just like implement all the components. So they all require Tomcat MySQL component A. Some of them require component B, C, or D. This one uses a resource that comes out of component B. This one actually has a dependency that it needs to chain. So just implementation things that won't fit anywhere else. And this was kind of cool. And then we realized, well, actually, we're trying to get away from duplication and we're trying to abstract everything. So the fact that we know that Tomcat MySQL and component A are needed on all boxes, then that's kind of a okay time to use inheritance. So we came up with this, like a slightly tighter system where we had profiles application, and then we have our X, Y, and Z inheriting just with the implementation differences. Really dry mouth. So once we implemented this, it solved a lot of pain for us because we could do all of our implementation tweaks that the business wanted. We could do it at this code layer. So at the bottom, we're still managing resources. Like all this is just to do one thing, and that's to manage our resources. Yeah, this is Puppet. So to manage those resources on the system, so we've got our component resources. Sorry, our component modules, which is our sort of resource modeling layer. So this is your SSH, this is your Apache, this is your component A and component B. So on top of that now, we've added this other layer of abstraction to handle implementation. So here we model all the resources, here we implement them. And this actually did like solve a lot of problems, and it didn't just solve that problem because I told you this is based on a real world problem. In reality, it was far worse. We actually had, to explain it properly, 2 different types of deployments, and they were made up of like 15 different server types each that all had a load of stuff in common. It was spread over 10 plus locations. Across all those locations, there were 4 different environments, and absolutely every installation was a massive edge case. There was just no consistency. And my slides weren't big enough to like properly explain it all. So I simplified it. But the lessons we learned from this is that granularity is really good. So breaking everything down into components will really let you visualize what you're trying to do and then understand how to put all that stuff back together again in a way that works technically, not works logically. Because you can't assume that business logic will directly translate into technology, because sometimes it just doesn't. And we also learned that abstraction is really awesome, but that's really nothing new. It shouldn't surprise anybody, because abstraction's been like a core principle of coding forever, since coding was invented. Like, not, I shouldn't say functions, but like functionality is abstracted by a method. You know, methods have classes and modules to abstract them, and they're abstracted with libraries, you know, and Puppet is code, we said that earlier. So, you know, abstraction is good. And not only is Puppet code, but Puppet is all about abstraction. So we abstract data out of Puppet with Hiera. The whole types and providers thing is all about abstraction. Resources are abstracted by classes. And we even take those classes and we abstract them with modules. So what have we actually done here? We've just abstracted modules with profiles. So it's following on the same theme that like Puppet does every day. So focusing a bit on abstraction. So we've managed to turn now our business logic into a technology stack, which is awesome because it solves a whole load of problems. And we kind of got to thinking, well, can we translate that back into business logic? And it's like, yeah, why would you even want to do that? Well, you might want to do that, and I'm going to explain why. So let's take an example configuration model. So this is like a UAT cluster node. Let's just say it needs all this like base stuff. It needs security, users, NTP, SSH. That's what the whole infrastructure needs. It also needs our custom app. It needs a Tomcat server. It needs Jenkins, and it needs to do some implementation there. It includes MySQL, and we need to use a resource from the MySQL class. So that's what we want to end up with at the end, as the end result. So what we started doing, we started thinking about the users. We started thinking about who is actually using this stuff that we're doing, like who's involved. So our fictional users, John, Susan, and Bill. So John's a sysadmin, right? He needs to know that all the servers have kernel hardening, NTP, SSH. Right? He really cares about that stuff. He wants to manage all the packages, all the services, like every resource, because he's responsible for maintaining everything. That's his job. Fine, and he's probably going to be your puppet master. Susan, she's not a sysadmin. She's an application specialist. So what she cares about is that this cluster node has a MySQL server, a Tomcat server, and Jenkins installed. Yeah, she doesn't care about server hardening. She doesn't care about NTP. That's all the things that she cares about. So then we got Bill. So Bill's an IT manager, so he doesn't give a crap about any of it. He just wants to know that it's a UAT cluster. That's it. He doesn't care what packages you've got on there. He doesn't care even if you're using Puppet to do it. He just wants it to be a UAT cluster node. Yeah? So what are they actually caring about? So John's caring about modeling all the resources. That's fine. Susan's caring about the technology stack that's built on top of that. And Bill cares about the business logic. So when we translate that into Puppet, given what we've just done now, we know that our resource modeling is done in component modules. That's fine. So that's like John's area, managing everything. We've now got this profiles layer where our technology stack is defined. So that's kind of where Susan fits in. But where are we going to represent this business logic for Bill? Yeah? So this is where roles come in. So the purpose of a role is to represent business logic, not technology. So we're talking about the role of something in the environment, not actually what it's running. And what we saw earlier, they can be really different things. So business logic. And the purpose of them is to define a set of technology stacks, so profiles, that make up itself. So what defines itself? Yeah? And this allows the business to manage this allows them to manage how it looks, because it's important for them to know and manage how the infrastructure looks. It's just not feasible for the guy implementing Puppet to just take that and bung it in Puppet. So we still want the business to have a view on how our infrastructure looks. We're not saying it's a bad thing. So there's one rule which I've always done with roles, and that's a node can only have one role and no more. So it can include as many profiles as it wants to define itself. If it needs 10 profiles to be a something, that's fine, but it can't be two somethings at the same time. So if a node requires two roles, by definition, it's become a new role. So like something couldn't be a lion and a kangaroo at the same time. It's impossible. It's not going to be a lion and a kangaroo, and it's not going to be a lion or a kangaroo. It's just going to be a lingaroo. You've created a new thing, yeah? I got to thank whoever actually did that image. So anyway, so roles have a one-to-one relationship with nodes. They have a one-to-many relationship with profiles, and all they do is implement profiles. They don't do anything else. So an example role might be a UAT server, and that might be all it does. It gets a base profile, it gets a custom app profile, and it gets a test tools profile. So these are just technology stacks. Whereas the UAT server, that's how it looks to Bill. Yeah, it's a UAT server. He doesn't really even care it's got this stuff in it. It's a UAT server. So then we go on to classification. So no classification is just Puppet telling a node what classes it should be. It should apply. So for the purposes of this design, like node classification just assigns a role to a node. That's all we're doing. And the roles themselves, they expose all the profiles, they do all the work. So if you remember the slide with Node Basil on it earlier, that's a lot nicer now, because now Bill can look at this and go, what is craig.puppetlabs.vm? Oh, it's a UAT server. Awesome. Or what Bill's more likely to do, because he's pointing clicky, is use Enterprise Console, where he's going to see the exact same information. So let's just get back to our stack now. So we know we want to model these, we know we want to manage these resources. We know we want that to work. We know we've got our resource modeling layer here, which is all of our component modules. We've already added our implementation layer for actually implementing those component modules. And all we've done now is just add another layer of abstraction, which is our business logic. Yeah? So I'm just going to cover a tiny bit of terminology here when I'm talking about roles and profiles. Roles and profiles are Puppet modules. Like physically, they are modules in your module path. I'm not saying these are some magic classes that you import from somewhere, because you don't do that in Puppet anymore. So when we refer to roles and profiles, we're referring to Puppet modules that are called profiles and roles, literally, and everything else, which does all the stuff with resources, we just refer to as component modules. But it's the logic of how they talk to each other that defines that stack. So everything is a module. So naming conventions. So when you're naming your classes, you should be naming the component modules after what they're actually managing. So Apache, SSH, MySQL. The profile name should actually match the logical stack they implement. So it's a technical name that represents that stack. So a database stack, a Bastion stack, an email stack. But the roles should be named with business logic. So they should be UAT server, web cluster, application, archive. These names need to be names that Bill understands. Yeah? Or that Bill wants to, that matches up with what he's got on his network diagram. So we've looked at implementation, and we've looked at components, and we've looked at business logic. What we haven't really covered is data. So when I was writing this talk, I wasn't sure whether to do an overview of Hiera or not, but actually I'm quite glad I am, because I didn't want to assume that the whole room actually knows a lot about Hiera. So if you do, we're going to come back onto how this fits into roles and profiles in a second, but I'm just going to run over basically what Hiera is. So this is very much like the same issue we've got with implementation. If you're just managing your dev environment with Puppet, it's actually going to be pretty easy. And you can just put a whole bunch of variables in Puppet, your NTP server, your DNS server, your mail server, everything. Just put them in Puppet, it's fine. Puppet's got variables. Then you get your QA and your production server off the same code base, and it starts to hurt a bit more, because now when you deploy stuff to production, all this data's got to be different than when it's on QA or when it's on dev. And yeah, it becomes hard to model that in Puppet. And that's assuming that you're only doing this in one data center. If you were to be running your dev QA and production across 3 data centers, you're going to get into a lot of pain. And what you're soon going to realize is that managing data in Puppet is really, really hard. Puppet's not a database. It's not built to store data. It's built to manage configuration models. So what you end up with in Puppet, you end up with stuff like that. And we've just seen in the danger slides thing, if you start using the if statement for everything, then you got a fundamental design flaw. So this just will have, there's no other way around it in Puppet. So with Hiera, that becomes a lot easier. You abstract all that logic out of the way, and you just say, Hiera, I want this value, give it to me. And the way Hiera works behind the scenes, it uses fact-to-facts to determine a hierarchy of lookups. So it looks like top-down for overriding stuff. So a common one people start off with is they say, check if you've got a value for my host name, and if you don't, then check if you've got a value for my environment, and if you don't, then just give me what everybody else has. But you can have that hierarchy based on everything. So the idea is you can have all your common data, and then you can override depending on location, depending on the environment, depending on just the host name. So all that logic is just done from within Hiera now, not from within Puppet. And the awesome thing is you can do this without any coding. Yeah, because Puppet is Hiera is just like a database, so no coding to get all that logic. So when we talk about, if you've been around the Puppet community for a while, you've probably heard a lot about separation of data from code, because it's the big buzzword at the moment. But it's because it's correct, it will just solve a lot of your problems. So not only does it solve the problem of your code and your hierarchies, but if you don't have hard-coded data in your Puppet modules anymore, they become incredibly easy to share. You can upload them to the Forge, you can share them with other teams. And I touched on it earlier, but your infrastructure configuration can now be managed without needing to edit Puppet. So, Bill can manage things on your infrastructure now. You don't need to know Puppet to, if your job is in a support role and you need to go and change an NTP server, you really shouldn't need to know Puppet code in order to just go and change an NTP server. Yeah? With Hiera, you don't need to. You just edit it in Hiera and Puppet will read it. So where Hiera gets its data from, Hiera has pluggable backends. So by default, it will look in a series of YAML files on disk, which you lay out in a certain way in your hierarchy. But you don't have to do that. There's a bunch of other backends available, and they're easy to write yourself as well. So there's a GPG backend, so if you're storing all your data in like Subversion or Git, and you don't want your MySQL root password known by the whole company, you can use that. There's an HTTP one for querying data from like a REST API. If you want to use MySQL or Redis, there's database backends. Or if you just don't like YAML, you can just strip it out and put the JSON one in. So where you get your data from is up to you. You can configure that. But the data source is abstracted from the code. So in your code, you don't care. You're just saying, Hiera, give me this value. You don't care where Hiera is getting it from. Again, it's abstraction. It's all about abstraction. So we use Hiera to abstract data from the code. And our components, our component modules and our profiles can now source data directly from Hiera. So just to note, because I get asked about this a little bit, like the difference between profiles and Hiera is we're using Hiera to model our data, and we're using profiles to model the implementation of our components. It's a very different thing. So if we have a look at our stack again, so that should be fairly familiar now. So for our resource modeling layer and our implementation layer should be to use Hiera to get the data that it needs. Yeah? So we're almost there, but we're kind of missing a big part of the overall puzzle, which is classification. So classification, as we just said, it's assigning classes to a node. That's all it is. It sounds like it's really fancy, but that's all it's really doing. So you can classify stuff within Puppet code, like the old nodes PP model or a site PP model, just using node declaration. That is classification. Or what's more sort of popular these days is using an external node classifier, or ENC. So you tell Puppet to go elsewhere for this information. And it doesn't matter how you do, like to design this model of Puppet, it doesn't matter how you classify your nodes. So you can use Dashboard, you can use Enterprise Console if you're PE, you can use Foreman, you can still use Site PP, or you can write your own custom script. They're dead easy. So the point is that an ENC should only be classifying a node to its role, and it shouldn't be doing anything else. Yeah, that's all it does. So if we look where it fits on our stack here, so we've got data feeding our resource modeling or implementation layer. Our classifier now determines the business logic. And that is the stack. There's no more boxes coming up. So the key benefits to this is we've reduced this node level logic to just a role. So we're not saying now node Basil has to have all this. We're just telling Puppet what node Basil is. And we've got the ability now to be really flexible with implementation. And that's going to make our edge cases a lot easier to solve now. And trust me, if you're sitting there going like, oh, my company doesn't have edge cases, just wait till next week or next month, you'll get them. And the business logic improves manageability by non-Puppet users, and so does the data separation. So, okay, I've used the word should, and I've tried it. I've made it sound like this is like what you must do. It's actually not. This is just something I found worked for me. The point I'm trying to get across, and is what I actually said in my blog post originally, that I'm not trying to say that this is the way to design Puppet. I'm trying to say it's a way to design Puppet, and you should be thinking about a way to design Puppet. Yeah, not just jumping in like we did way back then. So just quickly, I'll just recap some of the feedback that I get. So this is really annoying me. So I get asked like, well, can I implement this design without roles? Do I even need roles? Can't I just have profiles? Like a lot of people understand the concept of profiles, but they just don't get why you need to have roles. It's like, well, yes, you can do what you want. If you lose roles, you just don't get the abstraction layer that exposes the business logic. If you don't care about that, then don't do it. I get asked as well, like, can my roles be defined in my ENC? Yeah, I mean, yes. There's absolutely no reason why you couldn't use your ENC to define the roles. I like to keep it in Puppet, keep it in Puppet code because it is functionality, even though it's just including profiles, and I want that to be versionable. But if you put it in an ENC, it's fine. And the last one I tend to get is, yeah, can I just use Hiera to define profiles? Because you can use Hiera include and stuff, and you can actually use Hiera as an ENC, and I know some people do. And again, technically, yes, you can do this. You are going to lose the flexibility to implement code logic in profiles, and it may become restrictive. There is actually a really cool thing that Ari Pina showed me the other week, so I've just put on the slide, where you can actually do almost everything that you do in Puppet Manifest in Hiera. Don't worry about the URLs, I know Dawn's going to publish the slides. So, no matter whether you adapt this kind of principle or make up one of your own, the fundamental concepts that I was trying to convey is first abstraction. I mean, really, it is just the key. It's why Puppet works, so there's no reason to deviate from that. And it's also decoupling this business logic and our implementation and our resource modeling. That's really powerful for just helping you get out of problems. Separating data from code. You're not going to meet many people in the community who have separated their data from their code and then thought that was a mistake and gone back to doing it the old way. Trust me. And reducing this node level complexity. So it's just we don't have all that stuff in a node anymore. So there's a couple of recent, this topic's been talked about a lot recently, and I thought it was worth mentioning, if anyone's really interested in this stuff, some other stuff to look at. Adrian Thibault, who works for Puppet Labs in our ops department, he wrote a really awesome blog post that it's along similar lines as this, and he sort of compares Puppet code to Lego bricks and stuff. My original blog post, which I've really got to get around to rewriting because I never expected it to be popular. And Ari Pina also wrote recently this module structure Redux post, which is not strictly aligned to what we've been talking about today, but it's about how to write really good standard modules, and it really ties in with all this. So that's three things that you should really read about. That first bit is a complete lie because I haven't uploaded them yet, but I know Dawn's going to be putting them on the Puppet Lab site, so don't worry. And if you want to follow me there or bug me on IRC, you can. And thank you very much. And if anyone's got any questions, I actually don't know how much time I've got left.
Yeah, we have time for questions. We have about 10 minutes.
Oh, cool. 10 minutes and no questions.
I don't have a question, but I was going to just point out that Adrian is no longer in our ops department. He's now one of my developers. I took him.
Oh, I'm sorry. Okay.
Awesome. Yes. Surely someone has a question. He got up there, he talked really fast for 35 minutes.
Oh. Thank you. Oh, thanks very much, everyone.